All right, welcome to 4.2 Intercepts. So last time we talked about function notation and how to do operations on functions like adding and subtracting, and then like also substituting the answers in, evaluate. I guess that'd probably be a better way. Okay, this unit or this lesson we'll be talking about intercepts, specifically for linear equations like y equals mx plus b. So let's fill in some of these spots. So an intercept is where a line crosses the x or y axis. Okay, so a linear equation, most of the time you will have an x-intercept and a y-intercept. And we'll talk about some other examples where you would only get one or the other. Okay, the x-intercept is where the graph crosses. I guess this should be the line, where the line crosses or intersects the x-axis. And the y-intercept is where the graph crosses, again I think this should be the line crosses or intersects the y-axis. Okay, once you find the intercept, you then have to be able to interpret it. Okay, or explain what the intercept means. Okay, and that's really talking about when we have word problems. When we have regular, like we're going to start with, we can't really interpret it until we know the context. Okay, so let's just get started. It says, it is fairly easy to just look at the graph and determine the x and y intercepts. This is fairly meaningless unless you understand what the graph is telling you. So graphs in itself doesn't mean a whole lot, okay? But when we have context like word problems or a savings account or I don't know, come up with some other examples where it actually makes sense. So let's just get started with ones where it perhaps does not make sense a whole lot, but we'll start understanding as we go on. Okay, so here we have a linear equation, and they want us just to list what is the x-intercept and what's the y-intercept. So x-intercept for this one, okay, so this is our x-axis, and we want to know the x-intercept is where it crosses the x-axis. All right, and that will be right here. We always write our answer as an ordered pair. So maybe I'll write this down. Ordered pair is always x first and then y. Okay, so if we're in this example, we're going to do x first. That gives us a -3. And then the y value is 0. Okay, and then if we're going to do the y-intercept, okay, again, we're going to have an ordered pair, and it's going to be the point where it crosses the y-axis. So here's our y, this is our y-axis, and it crosses at this point, which would be 3 positive, or not, sorry, x is first. So x first is 0, and the y value is 3. Okay? Can't believe I accidentally made that mistake. Okay. All right. Here's another example. Here we can have more than one x-intercept. Okay. But to have it be a function, there's always only going to be one y-intercept. Okay. So here we go. Again, we want to find these points. These are going to be our x-intercepts where the graph or the line crosses. So for the x-intercepts, we're going to have 3. Okay, and some of these you're just going to have to make an educated guess. Okay, can't really see that it crosses at a perfect location. I would say for the first one, maybe looks like -2 1/4. So -2 1/4. Okay. And then for the y would always be 0. So for all of these are going to be 0. The next one, that looks about a half. And for the last one, that looks like maybe 1 3/4. Okay? As long as it's a good educated guess, then I am fine with that. Okay, and then we're going to do the y-intercept. So y-intercept is where the line crosses the y-axis. So y-intercept, that looks like it's at about 0, 2. So remember, x is first, so x, and then we go and find the y. It would be 0, 2, if that helps. Okay, so 0, 2, x, y. Here's another linear equation. All right, so here we can't, so let's write our x-intercept. X-intercept, okay, again, we're going to have an ordered pair, but here we can't see it. All right, so in this situation, what you would do is you would need to interpolate. So just kind of come over here. Okay, I think on the test and the homework and things like that, you'll never have to interpolate. Okay, but I think this one ends up being 1/2, or sorry, 1/3, or sorry, 15, 15, 0. Okay, and we will learn how to actually figure that out in the coming lessons. Okay, so it doesn't have to be a guess at this point, but we'll just stay with that. Okay, so y-intercept. So don't think that there isn't going to be an x-intercept if you can't see it cross the line. Okay, if it has a slope, which it does, it will always cross the x-axis. All right, okay, so we want to write down our y-intercept. So x will always be 0. So if we look at this, x value here is 0. And then the y value is right here, which would give us 5. Okay, next we have another graph. Okay, this one crosses the x-axis twice, here and here. So our x-intercepts are going to be, looks like 0 and 0, and 4, 0. Okay, and then for our y-intercept, it's the same point as one of the x-intercepts, and that's just fine, 0, 0. All right, so x-intercepts and y-intercepts from graphs. All right, let's keep going. Finding x and y-intercepts from an equation in standard form. Okay, so standard form looks like this: ax plus by equals c. You probably see linear equations more often in intercept form, which is y equals mx plus b. Okay, they both have pros and cons, and we'll learn more about that and how to switch between those. Okay, so to find the x-intercept, we plug 0 in for y, and then we solve for x. To find the y-intercept, we plug 0 in for the other variable, or you could say solve for the y. Okay? Or for the x. Okay? So if we're trying to find x, we set y to 0, and if we want to find the y-intercept, we plug 0 in for x. Okay, so let's do some examples of doing that. Okay, we want to find the x-intercept. Okay, so if we want to find the x-intercept, we want to find when y equals 0. So again, if we do a little graph or something, the x-intercept will always be when y is 0. So we're going to do x plus 0 is equal to 5, and we'd end up just getting x equals 5. Okay, to find the y-intercept, okay, we're going to, so y-intercept, x is always 0, so we'll plug 0 in for x. And we just get y equals 5. Okay, so those would be our two solutions. Okay, well, sorry, that's our x value. Okay, we should probably write it as an ordered pair. So the x-intercept would be 5, 0, because we just said that y is equal to 0. And then for the y-intercept, we know that x is 0 and y is 5. Okay? So always write intercepts as ordered pairs. Okay, here we have another example, x-intercept. Okay, we want to find the x-intercept, we're going to set y equal to 0. So we'll get 3x plus 4 times 0 equals 12. Well, 4 times 0 is just 0. So we'll just have 3x equals 12. And then we've solved problems before, so this shouldn't be anything new. We want to get x by itself, so we'd divide both sides by 3. Okay? We get x equals 4. So to write it as an ordered pair, we'd have 4, 0 would be our x-intercept. Okay? And then we'll do the same thing for the y-intercept. We want to find y-intercept, we're going to set x equal to 0. So we'll do 3 times 0 plus 4y equals to 12. 0 times 3 is 0. So we're just going to divide both sides by 4. And we'd get y equals 3. Okay, now we write it as an ordered pair. Okay, so we just said that x is 0 when we find the y-intercepts, and y equals 3. Okay, so those are our two x-intercept and y-intercept. So try and do these by yourself, right? Okay. So these are actually not in standard form, and it doesn't really matter. Okay, we'll do the same thing. So we want to find the x-intercept. Okay, so we'll set y equal to 0. Okay, 5 times 0 is 0. So we'll get 0 equals negative 2x plus 10. Okay, and to get x by itself, we would subtract 10 to both sides. So remember, when we're solving, we're doing like the opposite of PEMDAS. So we'll do addition and subtraction first. So that would give us negative 10 equals negative 2x. And then we would do multiplication and division. Okay, so just to make sure, since we're multiplying these together, the opposite of multiplication is division. So we'd divide both sides by 2. And we'd end up getting negative 10 divided by negative 2. That gives us a positive 5 equals x. So the x-intercept would be 5, 0. Same as the y-intercept. We set x equal to 0, so we'd have 5y equal to negative 2 times 0 minus 10. That is 0. Negative 2 times 0 is 0. So we'd have 5y equal to negative 10. And then to get rid of that y, we're going to divide both sides by 5 for the same reason. So y equals negative 2. So the y-intercept would be 0, negative 2. So that would be our two answers. All right. Okay. Next thing, a lot of the same. So here we want to find the x-intercept. We set y equal to 0, so we'd get negative x plus 0 equals 0. Okay, we could, since there's a 0, we can just kind of ignore that. Okay, that's what we've done in the past. And then to get rid of that negative, we could divide both sides by a negative 1. And you just get x equals 0, which makes sense. Okay. All right, same with, so the y-intercept, or the x-intercept would be 0, 0. And then with y-intercept, we set x equal to 0, so we'd do negative 0 plus y equals 0. Okay, that doesn't really matter. Probably shouldn't do x's, just cross it out. We just end up getting y equals 0. So our y-intercept would be 0, 0. Okay, let's do another example. So many examples. Okay, x-intercept. Okay, we're going to set y equal to 0, so we get negative 5x. And would y plus 0 would just give us nothing. And then plus 15. So we just want to divide both sides by -5. That would give us x equals -3. So the y-intercept would be -3, 0. All right? And just remember, this goes here because for an ordered pair, or for a point, it's always x comma y. And we just said that x is -3, and we use that y equals 0 to be able to solve. Okay, so that's why we have a -3 and a 0. Okay, next we have y-intercept. We set x equal to 0, so -5 times 0 plus y is equal to 15. Well, that's nothing. So all we'd really have is y equals 15. And then for an ordered pair, for our point, would be 0, 15. Okay? And so many problems. All right, same thing. I'm just going to try and go quicker. I'm not going to, I guess we have 2 left. I'm just going to just do it. Okay? Okay, and then the last one, x-intercept, set y equal to 0, so we'd have 6x equals -12. Divide both sides by 6, get x equals -2. So the intercept would be -2, 0. And then for the y, we need to get y by itself. So we'll divide both sides by 4. And get y equals 3. So the intercept would be 0, 3. Okay. All right, well, if you have any questions, please let me know. Hopefully this wasn't too much of a learning curve or whatever. Okay, anyway, all right, we'll see ya.